Okay, that's our indication at the top that we're all set up. It's hard to see if you're in the Zoom class, or I guess you can see from the Zoom controls it's recording. In the in-person class, you're looking for that thing right here. Then you have to click this away real fast before we get some crazy feedback. There we go. This is the most boring part of the class. We've got to run the clock. We start officially exactly at 6 o'clock. But if it seems like we're already started, it's probably because a student question was asked. That's the only time we might get going early to address any earlier question. I try to arrive at the classroom physically about 30 minutes early, get everything set up here on my end of the technology, logging in on Zoom about 20 minutes early. So if you ever have any extra questions that you want to discuss right before class, I'll be available for that as well. But welcome to the new semester, folks. Spring 2025. I'm not too sure if I said 2025 on that link that we're recording on, but we'll fix it when we have to. Any questions whatsoever before we get started? Okay, that's a really long, uncomfortable silence, but I'm practicing to do the semesters to wait about 10 seconds for a class like this when I call for general questions like that. I'll probably more likely be between 5 and 10 seconds. The issue is this is a pretty complicated class that we're running. Anytime you're looking through an ISU class schedule registering for a class, if you notice there's a section that goes like section 3, section 33, or section 5, section 55, these are totally linked sections. Essentially what ISU is doing is running these together as one overall class. And it's really pretty weird. This is something I want to mention right away. It feels like there's a bit of false advertisement here because Math 3350 says it's fully online, but it's only online through the Zoom participation portion of it. It does require an in-person exam at an ISU testing center or a nearby testing center if you're far remote. Aside from that, there's also the little extra difficulty where if some of the class comes in through Zoom and some of the class is here physically in person, there's always a little bit of latency and lag that goes on. One of the things that I often forget, and I hope for the Zoom site to remind me often, is if there's a question asked in class here physically, this Zoom camera right here is not really that great as a microphone. So you have to really speak pretty loud, and that's a weird thing to do as a student. So I might oftentimes repeat back a question when it's asked, even in the classroom. That's another thing that seems kind of weird at first, but we'll all get used to it. Other things to mention are, let's see here. I think those are the main things I wanted to mention right out of the way. As far as the book goes, I mentioned in this course that you can have any edition of this textbook, even the very first edition, and that will work totally fine. It's got all the right content. The major changes are the actual homework exercises, but all of our homework exercises in this course are pre-typed out. So even if you're working in a very old edition, the very first one, you'll still be doing the same exact homework questions. I think the table of contents is identical as well. So our goal today is really not to do too much. This class ends at 7:15. We'll probably go to about 7 o'clock. We're introducing the course, introducing how to work with the Moodle website, and get a little bit started on just dealing with a couple statistical problems in chapter 1. But maybe one other thing to include here is for the folks in Zoom, it's really hard to know what is really going on in my screen. If you're in here with us today in person, then you can just see on the projector how all these controls look. But for the Zoom side, let me open up this document. I took a screenshot here to just give you an indication of what I'm looking at. Actually, let's take a new screenshot. So if you're participating today from the Zoom side, this is pretty much what my setup is always going to look like. I lose some real estate for the screen on the left for this annotation tool. This tool right here is supposed to hide away, but you know how technology goes. Something's broken with the installation on this, and it's not something that's easily correctable. Over here, this is what the participation window looks like. And what I would prefer is to have a second monitor where I could actually see your faces if you want to be on camera. But the technology here is limited. We are limited on the resolution of the projector on the one monitor here. So instead, I usually go by this little sidebar. You can do a lot of things as a Zoom student, and this is relative to the people here today in person. If there's a day you ever have to come in through Zoom, maybe it's a bad snow day, snow event or something like that. So you can use your Zoom controls to do things like reactions, like thumbs up, raise hands, all sorts of things. I try to do my best to look to this side very often to see what's going on. And probably the best way to participate in the class through the Zoom side is definitely using voice with a working microphone, but that doesn't always work out for everybody. So I do try to be accommodating for if you're typing out a message through chat, I always try to respond to those as well. Sometimes it does even make sense to have your mic open even for 1 second, say a noisy environment, something like that. I do have one difficulty with chat though, and I would need help from pretty much everybody in the class on this. The downside with using chat is that my notification that a chat occurred is through a box right here. It pretty much turns into like a number one to say I have one pending chat or something like that. And for some reason, that's easy for my eye to miss. So if you ever notice a chat comes through, but I didn't quite see it, anyone in Zoom, anyone in class physically can just say, hey, Mike, you missed a chat. And I'll be very sure to open that up and read it out. I do have to read out the chat so that everybody can know what the question was. So keep that in mind. If you want to send a direct message with something, a personal question about the course, things like that, that might be better for an email rather than a chat through Zoom. But any questions so far, folks, about coming in through the Zoom site and participating? Okay, let me close this out. Oh, and next thing I'd like to take a look at is just going through the resources that we have here on the Moodle website. We'll take a look at the syllabus, but not a careful reading. We don't want to spend too much time on that. I'm assuming that lots of folks have looked at it over it already. If you haven't had a chance, then this will be a good thing to do right after class or before the next class. Down below, we have the announcements link. I'll be making good use of this throughout the semester. And this is a good thing to click on even if you join the class before my very first announcement. It keeps a record of everything that was there. So if you join on January 9th, that's okay. You can still read the old announcements. Down below is the book bundle link. I deleted this, come right back like a possessed Ouija board or something. So I don't know what its purpose is, but for our class, I believe this is totally irrelevant. Let me know if I'm wrong on that. We're all, as instructors, still trying to learn about this book bundle program. The information on it is not very spectacular. I think ISU itself is trying to figure it out, it seems like. Down below is the Zoom link. Everyone on the Zoom site has found this, but I want to just throw out there that if you are in the in-person section, you are welcome to use this link on days that it makes sense. I'd say if you signed up for the in-person section, it's best to be here physically, but no hard feelings if you decide to use this Zoom link. And conversely, if you're here through the Zoom side, but you just happen to be in town, you'd rather join the class in person in Ch.1, you're welcome to do so as well. Any questions or comments so far? Okay, down below, this is where all of our class recordings are going to end up. It's just a playlist directly on the YouTube website. Oh, sorry, did I miss a question? Okay, so the playlist here is currently empty, but this will get propagated out pretty soon. There's a lot of little things I have to do after class, moving files around, dumping files into playlists. Sometimes it's actually easy to make a mistake there and put our statistical class lecture in like a calculus recording. So if you ever notice something just seems missing here or wrong, something like that, don't hesitate to directly email me. I'll get that corrected right away. Let's close that out and just keep on going. Below is the big calculator that we're going to be using in this course. RStudio is a fantastic piece of software for statistical computing. In fact, I've taught this class for this is the 12th time since 2010. I've taught quite a few students that work for the Department of Energy or the contractors that work for it, just over there on the Willow Creek building on the other side of the parking lot. They as well use this kind of software because it is very heavy duty industry software, which happens to be open source all at the same time. I wrote down here a great article for more motivation on why this is a good choice for statistical computing. And this is just a blurb from my opinion on why it's also a great choice. Consider this optional reading, but if you would like to learn more about RStudio, this is where you can find out more information. So RStudio, again, is the big calculator that we use in our course. When it comes to other things like the TID4, you certainly wouldn't be penalized for knowing how to use that calculator and deciding to do so, but you would eventually encounter some difficulties. Sometimes our data set is large, over 100 observations, And it is a really huge chore with the TID4 to get that much data imported. What about Excel? Well, Excel is a better program. We could do this course well with Excel, but it does have a downside. There is a maximum size for an Excel sheet, for example, and reasonable data sets that are generated all of the time in industry and government easily exceed what Excel can even handle. Very fast. It's pretty impressive. So what's R have going on for it? Again, it's software that's used routinely in education. It's used in industry. So if you had to pick one piece of software to learn relative to statistical computing, this would probably be the best choice. The type of program it is considered an interpreter, if you're familiar with what that means. It means you don't compile your code, you use it pretty much like a calculator. You execute the code and it just gives you your output right away. So there's R, the actual program that we're going to use, and then below is RStudio. This is the base program language, R, right here. Usually when you install this, you probably would actually literally want to delete this icon. I don't think I can. This is an interesting setup workstation, so I'll just put it by the dumpster. We install something else on top of R called RStudio. This one is referred to as an integrated development environment for the programming students. If you're not as familiar with programming, don't worry too much about it. We're still using that pretty much just like an ordinary calculator. The upside to this is that R is a pretty basic package. This has a lot of bells and whistles, which just makes it easier to pick up the language and start working with it right away. Hayes asks, do we need to install the command line developer tools? I don't think so, but I'm going to go over the installation topics on how to get RStudio installed, Hayes. So let me know if that is exactly what we're doing there. Other questions at the moment? Yep, you bet. So this is pretty much what R looks like. An interpreted language just means you can do things like say 2 plus 2, and it executes the code for us. Up above is a script region. We'll use this a lot more. We'll do things along the lines of storing information inside a variable. Let's just do something basic. X, left arrow means we're storing some information in the variable X. For some reason, left arrow seems to be preferred for people who use our syntax. Equality works just as fine if you prefer to go that way as well. I typically go like this if I have to store a variable. I guess X is 23. And if we hit Control A, Control Enter, we run the entire set of code and get some values out. So I think what's kind of amazing about R running through RStudio here is it already knows what data type you're dealing with. There's a lot of extra things that you would have to do in a different programming language to get this value stored here in the environment. But even better so, what RStudio allows us to do is import the data set by pointing and clicking. That is actually the major reason why we like RStudio, because trying to direct your file system to the actual file to import it to R, that's actually kind of a nasty task to do every single time. So this is the calculator we'll be using quite a lot. I don't want to do too much on it today, instead just discuss the installation, because we want to work more on this thing when we're back on Thursday, with everyone having a good shot at getting this installed on your preferred machine. But before we close this out, any questions at the moment while we're looking at it? Yeah. That would be used in the course, yes. Yeah. So that is our Baldy textbook for the practice of statistics and life sciences. And you're welcome to have any edition of that textbook. So I would recommend go for even the first edition or the second edition to save the most money possible. Other questions so far? Okay, let me close this out for the moment. And instead of demonstrating RStudio, let's discuss how to install it. If you come back on Thursday and all you've done in this course is install R and RStudio, then you're considered caught up and good shape for the pacing of the course. So installing RStudio is done through this link right here. But there's actually a couple things that it directs you towards. Let me just accept all cookies and hope for the best. So scroll down below. There's a two-step process. First step you have to take is install the base language R itself. So let's just demonstrate what that looks like. You would next click on this link down below right here. And just to go slowly, if you're following step by step, we're clicking on this link here from the Moodle website, RStudio, direct us to this location, scrolling down. First, install R. Clicking on that takes you to a pretty old looking website, but remember this is an open source project, so they don't need a lot of bells and whistles here. This does just fine. Pick your favorite operating system, Linux, Mac, or Windows. For a lot of machines, the one we're using here, I would have to click Windows. Next, go to Base. We just need the base package of R, for example. And this is the download link that you'd want to use for the Windows operating system. So the moment I click on that, I'm ready to go. I can't actually install anything on this environment, but at that point, you can install R. Once you install this program, you get this icon that you can have on your desktop. But again, I would not worry about that one. Running the course through this will work, but it's a lot of work. If you open it up, you'll notice it's very bare bones. You have to know your syntax extremely well. There's no help in this program. So once we do all that, we have R installed. Then we just go back to this two-step process, go to the next step. Now we're installing RStudio. This is the actual program that you're going to be launching whenever you're working with R. So clicking on this, I clicked on it. Let me try again. Download. Oh, I see. That's kind of strange. I was expecting different versions. Well, what version did I install? I'm assuming this is a Windows version? Probably. If you don't have Windows, then that's no good. Keep scrolling down and okay, this is what I was hoping to find. Here's your different packages for Windows, Windows 10 and 11. I'm running this off Windows 10 and the other different packages. Looks like they have a lot of different distributions for Linux, so you can target those. So click on either this, or if you're using a Windows machine, this will work just fine. Mac users, the next most likely operating system in this class, would want to go way down here and click that distribution or this install file. So after you install that, you end up with this icon down below here. And if folks have any trouble getting this working on your personal laptop or your home desktop, don't hesitate to ask me anytime. I'll be very happy to help out and provide very big, great support for R and RStudio. In fact, once again, it's always good repeating, this is not considered a programming class. So anytime RStudio is involved, say in a homework set, if R is not working the way you expect, don't hesitate to send me a direct email just immediately. Maybe show me a syntax of what the code is or the error message is, and I'll help you troubleshoot it to get the code working out right as soon as possible. If I can't get it working out right, and all you're trying to do is produce some graphics for an example, I'll share that graphics with you so you can use in your report, and we'll just try to get it working on the next homework assignment. So again, RStudio is not meant to be a program where it's meant to hurt your grade in any way, shape, or form. This is just meant to streamline statistical computations so that we're focusing more on the concepts, less on arbitrarily tedious tasks. Yeah. There ought to be. That's a great question. Let me put here. I've seen a couple websites like that, but I've never actually bookmarked them and looked at them too closely. I want to add to my to-do list here. Oh, that's not the right one. 3350. To-do list. Let me put here, add a code repository for R syntax. I'll get that added up to the Moodle website, probably before we make it to next class. And I'll put it, I think it makes most sense to drop it right under RStudio. I'll add a good link for that well, I'm sure I'm going to find one. If someone happens to find a better link after you see mine, don't hesitate to share it as well. Other questions so far? Okay, so what have we done so far? We've pretty much just pointing at different links throughout here. We've discussed RStudio installation. Down below is a little bit more optional reading. There's an article I posted here on why study statistics. I think a lot of people have a good reasoning on why statistics has importance, but it's always good to see a new take. So this is written by a different university, BU. Another article here is just some study guides, things like that, on how to study statistics. If you open this up, it seems like a kind of not quite exactly right how to study math, but really it's all the same thing. This is a good study guide for how to study a biology course as well, in fact. Down below, the other resources I have here are the Blake lecture notes, and they should have been there. I need to add that to the file. Let me just add one more thing to my to-do list. Sorry for this distraction. Add Blake lecture notes. I'll be adding versions as a PDF file for compatibility, as well as a Microsoft Word version for folks that like to use that program. Then finally scrolling down to this segment, this is where the course pretty much will start on every class meeting. I'll always have it scrolled on the Moodle webpage, opened up with screen sharing, and will just be on the last concepts we discussed. I'll usually put a little message here to say we're on example 1, 2, something like that. All the documents we work on will come in folders with the relative material. These are blank notes at the moment, but they get overwritten with our class solutions as we start to solve them. So I'd say there's a lot of different ways to participate in this class. A lot of people come to this class with nothing but a pencil and a notebook and just take ordinary notes. That works totally fine. Plenty of people come in with a laptop, download the notes, and they annotate or type in notes as we work throughout the class. I think that works excellent as well. And still other people just grab these notes, completely print them out. They're essentially worksheets with loads of white space, and just by hand fill in the information here. The one thing you probably wouldn't do as a note-taking in this class is try to copy down the problems. That just takes way too much time. Copying down the definitions sometimes looks reasonable, but the definitions themselves are very verbose sometimes. So the best way to be effective at taking the notes is think about what goes in the white space. That's where you want to spend a lot of your energy writing, typing, or annotating on a laptop. And again, these are all essentially huge worksheets that we're going to fill out as the course progresses. The data sets and such, like we mentioned, are also published in the same document. And if we come out of here, the assignment right below is always indented, just to say it's attached to chapter 1. And it has kind of a similar format. I have a data set relative to the exercise, a PDF version of the assignment, again for extra compatibility, and a Word document of the assignment. Let's open up the PDF. And my assignments that I do write are very highly targeted to the actual lectures that we do, the lecture notes that are provided. So if you open up an assignment and you feel like, geez, I have no idea what's going on here on exercise 2, there might be something somewhere in the lecture notes in chapter 1, which is really targeting this kind of information, maybe in a slightly different format, but the concept is there. Some of these problems are a little bit trickier, and in that case, I try to make the problems quite similar so that we can really see how the concept goes in a new study, new situation. The different ways you can do this assignment, again, it all depends on you. If you feel like you'd rather print out these assignments and fill them in with pencil or pen, and then either scan, email me your copy, or give me a hard copy at the start of class and a class, that'll work completely fine. I think a lot of people these days in this class are using digital tools to just mark up their assignments. So you could download a file like this one here, or the PDF, digitally mark it up with your solutions, convert it to a PDF, and just save it to me. If it's in a Word file, you don't have to convert that one to a PDF since I work with quite a lot of Word files. But for other more exotic files, like say pages from the iOS ecosystem, those would be a little bit more challenging for me to open up. So a PDF would be appreciated in those kind of niche cases. So that's how the lecture notes, the homework assignments are going to work. And let's see here, that's pretty much the entire Moodle web course. I want to go over just a little bit of elements in the syllabus, contact information, office hours, stuff like that, but nothing too major. Any questions so far? Comments or concerns? Oh, sorry, I missed a couple chats there. Hayes asks, Can I print it out and fill it and send you a picture? Yeah, absolutely. That'd be a great way to work on the homework assignments as well. So what Hayes is asking is if it's okay to print out the assignment like these, then just mark it up with your pen or pencil. If you worked on that way, you're working on this class as if it's a very traditional class in a certain sense. Then all Hayes mentions is either scan it, take a cell phone picture of your work, send it to my email address, and then you're all set on the assignment. I think a couple of ways I run this course are a little bit odd. As far as the assignments go, I don't have a feature built into the Moodle website for accepting documents. And so you're asked for all of these to send your documents directly to my email address. I found that this works the best for a lot of purposes. Moodle has been kind of touchy with that kind of stuff in my experience. Other questions so far? Okay, well, with where we're at so far in the day, I wanted to take some time to look at the syllabus, not a careful line by line reading, but more just to scroll through some interesting portions. I encourage you to take a closer look when you have some time, if you haven't already done so. And then with the remaining time, we'll take a small look into chapter 1, do a couple warm-up problems. But first, let's take a look at this document here. It's already been revised. I think a student pointed this out. Thanks to that student, I forgot who it was. But this class meets on Tuesday and Thursday. I accidentally said Monday and Wednesday on this line down here. And this is the habit I try to get to on any document. The document has been revised. One of the things I usually do, but forgot to do so, is I like to tell you right away it's revised by doing something like this. So that's your indication there's been a change to that file. You might get some other indication through Moodle if a file's changed. I'll indicate here at the top of the file a revision happened, and any changes will always be in red. So far, these are the only two changes. So I want to focus mainly on the syllabus on the contact information, office hours, and course text for just a moment. Pretty much the way this course runs is we have office hours for the in-person section, office hours for the online section, but you're welcome to commingle. Again, even if you are in the in-person section, you can join the Zoom office hours. And even if you're on the online version, you can drop into the in-person office hours. There's no weird restrictions like that. It wouldn't make sense anyways. So my office hours run from 4:15, 5:15, Monday and Wednesday. Actually had a student on my office hours on Monday. I have more office hours on Tuesdays and Thursdays. But the first set is mainly intended for the online students, although again, anyone can join. My office hours are through Zoom, and it's the same Zoom link and password you used to join the class today. Other office hours I have are in room 220. This is the math center at ISU, which is struggling greatly. They have a hard time actually hiring student workers, even when they want to work. They're trying to get ahead of that issue some way, somehow. I think they have a change of leadership going on for the director of tutoring. That might be part of the issue. But I'm still in that room, 1 to 2 p.m. I was there today. I actually had one student as well that came into that one. And again on Thursday from 4:15 to 5:15. Now, I want to be really upfront with everyone in the class when it comes to these. In my experience, our schedules are extremely chaotic, especially for a night class with mostly non-traditional students on a satellite campus. These hours probably don't work for probably 70% of the class, potentially. Sometimes they're even more badly targeted. If this happens to be you, none of these hours makes any sense. Maybe you have class work at this times. Just send me a direct email, or we can work out a different time to meet. And another standard offer I give in every one of my classes is my email is essentially a type of, how would I say that? My email is essentially office hours in its own sense. For example, if you're working on anything, maybe it's a homework assignment, looking over lecture notes, watching a video, for example, any question that comes up, just don't hesitate to send it directly to my email address. I'm a pretty fast typist. I'm very responsive to my emails when I'm at my desktop. And so this is by far and away best way to get in contact. And just to be more specific, let's say you were working on a homework assignment. And let me pull up a homework assignment then. Oh, I didn't open a new tab on that. That was my bad. Let me try this again. If you happen to be working on a homework assignment, maybe assignment number 1, and you just got stumped on what is the sample, then one way you can do office hours, even if you can't meet on those meetings, is just take whatever work you have right here, take a screenshot, cell phone picture, any way you'd like to do it. Or if it's on a hard copy, maybe you printed something out, take a picture of that, send it directly to my email address here, and I'll work on that document and that problem with you to get through what the solution is, what the problem could be on the barcode, anything like that. So the standard offer here by email is, I'm available for office hours essentially at any time when you send in an email question. There's a downside to that, obviously, because I answer my emails usually between the morning hours to about 2 o'clock, depending on the day. I have no ability to really even look at my email right now, and they're hard to get to after class ends because that's usually pretty late at night. So you have to be patient if you decide to get help through email. But I check my email every single day of the week. Even if it's spring break, I check my email in the early mornings of the day. I will always go through my backlog of all emails sent before I go into other course prep for the day. So even if you have a lot of questions, send them all out. Even if you're working at odd hour, 3 a.m., you can still send that email. That's the best time to do it when the question's fresh in your mind. You're never going to be badgering me, and there's no way you're going to send me too many questions. Again, I mention this all the time, but I really mean it. Use this email here anytime a question comes up. I'll be happy to work with you. Okay, so that's my big spiel on getting help. Any questions about that so far? Okay, let's continue on through the rest of this document. We discussed the required software. The links on the Moodle website are better described there on actually finding these packages and installing them, but I felt like we should say it in the syllabus somewhere. We have our standard course objectives, a statement on homework, and on the statement on homework, this is a strong encouragement. Best way to learn really any kind of course content, whether you're in a biology, chemistry, physics, mathematics class, statistics class, is to collaborate. So you're all encouraged to work heavily together on completing these homework assignments. The only ask is that you write out or type out your own solution. So one file can't double count as a solution set for 2 students, but you're allowed to collaborate together to work on these problems. And the reason I put this essentially again on every one of my syllabus is because when it comes to learning any kind of information, there are different stages of learning. There's first being familiar, reading it in a book, seeing it in a lecture. That's the lower stage of learning. The next stage of learning is solving problems on your own. That's a little bit higher. Now you're not just following along. You have to complete all the information yourself. And the highest level of learning is when you're telling or teaching another student how another problem should go. Once you get to that highest level of learning where you're helping other students work through these problems, that's when these ideas really start to stick into your brain. And sorry, Hayes, for the question about RStudio, do we have to use RStudio for every class? I wouldn't say every class, but if I had to guess a proportion, I would say we open and actively use RStudio probably between 65% to 75% of class meetings. So definitely there's classes where we won't use it. A lot of classes where we'll use it quite heavily as well. Well, that's my spiel on homework. Here's where a lot of concern it gets raised by students, especially if you read through this portion of the course webpage. We're doing statistical problems using a heavy-duty statistical software, R through RStudio, yet the exams are going to be closed book, closed notes, and we don't use RStudio on exams. So how do we do the exams? That's kind of strange. Well, essentially this course is divided into 2 kinds of things. When you're doing a homework set, you're doing the whole process. You're looking through the concepts, you're using the R for the statistical computing to come out with the results. So it's a whole process report that you're giving to me. But when you're coming in for an exam setting, I do offer sample exam problems so you know what it looks like. It's all about the concepts. So I'm not asking you to use R or RStudio on an exam whatsoever. If there's a required graphic for the problem on the exam, I just print that on the exam. If there's a computation that's needed for, say, mean, standard deviation, anything like that, I include those values on the exam itself. So our examinations, which we'll have 3, either in class or in a testing center, they're purely concept-based examinations. They're not meant to be major uh, obstacles to the course, so people typically do quite well on these. If you're doing excellent on the homework, staying caught up, these exams are more of a formality. The final exam, however, is different. That one does use R in RStudio, but this one is intended as a take-home exam. I don't do this for very many of my classes, but this is the one class where it really does make sense. This class is all about statistical methods, so our capstone kind of like a project is the final exam, where I'll give you between 5 to 7 data sets from real studies where we have to decide what is the appropriate statistical method to do a top-down analysis on that data, providing all conclusions, all the setup, and so on. So really all that's going on there is it's just going to be a selection of concepts from old homework problems, not the same problems, but same kind of stuff as you've done before. So that's how the final exam will go. And the regular in-class exams, again, these won't use R or RStudio. In fact, all we really need is a basic scientific calculator, and you'll be all set for those exams. Well, any questions at the moment, folks? Exams or otherwise? Okay, let's keep on going through this document. Because homework is absolutely critical in this course, this is the one course where I made it nearly half the course contribution to your grade. So again, these homework assignments are really the meat and potatoes of this entire class. The exams are where we're going to double check our concepts from solidified knowledge. The final exam is meant to be essentially a big homework assignment, a big capstone project where we do a little bit of extra analysis. I signed this final exam on, not finals week, that's too short of a turnaround. I signed the final exam on closed week. It'll be signed on Thursday. It'll be on due on Thursday of finals week. So we'll have a 1 week turnaround on that final exam. Pretty much what it'll look like is once we're in this week on Thursday, we'll do a review. And then at the last 15 to 20 minutes of class, we'll open up a hidden file that says final exam, discuss it for a little bit, and then that assignment is released. So the finals week is pretty not so stressful when it comes to this class. The other classes will take the lead on that, I guess. Yeah, go ahead. Oh, that's a great question. It's one of those things where the question is, how long do we expect the final exam to take once it's assigned and then turn around and you send it in? I would say for the average student in this class, this exam could take anywhere between 3 hours if you're trying to do it really fast to as much as potentially 8 hours if you're just putting in a high level of detail on every single problem. If the student is slightly unprepared, I would say it could take a lot of additional time. My goal on this is to try to make this reasonable though. So again, the size of the final exam should be about the size of one of these assignments, anywhere between maybe 1.5 times of the length of a typical assignment. So as we go throughout the course, we'll get a good feel for how long are these assignments really? How much time are we spending on them? And I don't intend to make the final exam to be anywhere in the neighborhood of twice the length of a real assignment. I'll try to go between 1 to 1.5 times the length of a typical homework assignment to give more of a general response. Other questions about that so far? Okay, and once you have the final exam, essentially the major motivation there is we have to decide what statistical method fits the data. But then once you decide, oh, there's a two sample, I need a 2 sample t-test, something like that, you would just be scrolling throughout the Moodle website, finding the right folder that targets those concepts, and look at the methods. Everything will be fully described on how to handle that kind of data. And just like with any assignment, if there are problems with RStudio working, email me right away. I'll always spill all the beans when it comes to RStudio. There's no secrets on the syntax, how to run the program. I'm always happy to give full support on it. So far, like lost my track of where I'm at here. Here's the syllabus. Should just put that as a separate file here. Sorry, I'm having some trouble running this computer all of a sudden. There we go. So that's how the homework will work, the examinations. This is our breakdown for the course grade. I want to mention, say, a couple other things. Our day-by-day schedule looks like this. I do think I have a typo here. These are not meant to be in green. I'm going to have to fix that. I think my last time I ran this class in 2024, it was Monday and Wednesday, which mean we had two holidays here. I'm going to try to unflag that. I don't think I need to make that in the to-do list. It's a bit of a distraction. But the only thing that's firm in our schedule are the exam dates. That's the major thing I want to discuss. So these are great things to add to your calendar right away. And as far as the rest of the course content, my goal for this course is to get up to chapter 24, working with ANOVA. But these classes are really very interesting, I found. We attract a pretty diverse audience of students that work in biology, physics, pharmacology, stuff like that. And another interesting thing that happens with this class is it's 300 level, but the prerequisites to this class mention nothing about statistics. So if you took statistical reasoning, the introductory statistics class, you'll know a lot about statistics here going in. If you did not take that class, I'm not going to try to run through those concepts and leave those students out. I have to address all of the introductory statistics concepts because that prerequisite is missing. So that means for our class, chapter 1 is kind of a slow start. So is chapter 2. Everyone's getting on the same page for a little while for the first couple weeks. But then suddenly in our day-by-day schedule, we start to really get going once we get to the point where we're all caught up. That's chapter 11. At that point, we're working in the normal distributions, and we're doing statistical methods in earnest right around that point. So it's got a slow start. Sorry about that. But it's good to have everyone on the same page and not try to run too fast through the introductory concepts. Down below are further statements by the university. Every single one of these statements are important. This is a very massively important federal law, for example. This is something I like to mention in all of my classes. If in any class you're taking, including this class, something just doesn't seem right, you always have avenues to correct it. I would recommend going to your instructor first, but you don't have to just be satisfied with whatever answer you get. If you still feel like something isn't right with whatever is going on in the class, take it up a notch. At the math department, you'd want to go to Dr. Ralt. He's our department chair. Describe the situation, describe what didn't work when you tried to bring it to the instructor. If this doesn't work, then don't take no for an answer. If you know in your heart something is not quite right with what is going on in the course, these can be continued to elevate even further to the dean of the College of the Science and Engineering, to the dean of the students, to the provost, and so on. So just keep in mind, as a student, you have rights, and if things just don't seem right in your class, you can get about finding a way to make a remedy for that. There's a lot of statements we can make about all of these, so I encourage you, if you haven't read these statements before, do a careful reading. But if you read them once, they don't really change much from year to year, maybe different verb they selected here or there. So essentially, that's the whole syllabus. Is there any spot that folks would like to linger on for a moment to discuss further? Okay, well, with where we're at so far in the day, this is the portion where we don't try to get everyone so overloaded. Week 1 is always kind of an overwhelming day. And the more information I try to mention is just the more information that's hard to remember after getting through the first day. So my goal is to not go too far today. We're going to segue into chapter 1 now, looking into a little bit of course information. So as a student, you'd probably click on this file, download either this document or this. Well, download all of it. We're going to use all of it. For me, I have a thumb drive to the right where all these things are duplicated. So there's no difference between the PDF or the Word file. This is just different versions for compatibility's sake. One thing that does happen, though, with anything we do today in class, these files get overwritten with our solutions. So if you need to pick up the blank lecture notes to print it out, for example, they are available in this file here, once I remember to put them in. So here's our first chapter of the day, well, of the course. Before we get too far on this, for everyone in the class, for those in person, those in Zoom, how does this look? Does this look readable? Should we zoom in, anything like that? Awesome. Glad to see it's looking good, even in the back row. How about for folks in Zoom? Is this okay and readable? Okay, thanks for the feedback in there so far, folks. Well, let's begin. So statistics is very concerned with the dichotomy of the population versus the sample. Let's read through these definitions carefully. When we say the population, that's just the entire set of all the individuals, they could be people, objects, of which we want to describe. So for example, if we're thinking of a population of students, this class could be a population. If all I care about are the people here today in person and in Zoom, that's the population of students that I'm working with for this class. But then there's the population of all students at ISU. There's the population of, say, all students that run through a satellite campus, Idaho Falls, and so on. Really, sometimes the hardest thing to do in statistics is indicate what your population is that you're working with. Once we get that nailed down, we're in business. In inferential statistics, we don't have access to the entire population. That's fantastic when it happens, but oftentimes it's cost or workforce prohibited to actually get every member of the population into your study. Instead, we satisfy ourselves with a sample. We hope that it's a random sample. We'll have some things to say about randomization. A sample is just a collection of individuals that came from the population, so it is a legitimate subset. And anything that describes a sample would be a statistic. Anything that describes the population would be a parameter. Let's write down a couple statistics and parameters just to get a feel for this. So typical parameters we'd be working with, if our data is quantitative, we'll see other types of data are these ones. The parameter mu, the Greek letter mu, denotes the mean. Already, this is kind of a weird thing to say. We have to know somehow, some way, in a statistics class, that if I say mean, what I'm meaning is average or arithmetic average. So watch out for that word. There's a lot of different standard ways to indicate these kinds of things that sometimes doesn't always make a whole lot of sense. So when you hear the word mean, think average. Mu is the mean of, let me try again with that, the population. What we mean is the typical value. If you're taking a population of ages from a select of individuals, we would add up all those ages, divide by the size of that population, and then we would have mu. Next is sigma, written this way. It's kind of a tricky symbol to write. Imagine you're writing the letter O, but then just make it go a little bit further off to the right in that way. Sigma is equal to the standard deviation of the population. I'll abbreviate population to just pop, ran out of space there. So those are the parameters that we're interested in. Now, for most statistical problems, essentially all of the statistical problems that we're going to be looking at into this course, the sad reality is these are unknown. Our objective in inferential statistics is to approximate these values with reasonable quantities, or an entire interval of reasonable quantities, which we'll later on call a confidence interval. But we can always make a point estimate. This is the way we do it. If we can't calculate mu nor sigma, this is typical because we can't access everyone in the population, we study the population through a representative sample, hopefully through a simple random sample, some sampling design like that. We calculate the statistics. These are just describing the sample. And typical ways we write our statistics go like this. X bar, this is going to be the mean of the sample. And S is going to be the, I want to say standard deviation, but you notice that's a really hard word. I'll often abbreviate that to STD for standard, DEV for deviation, of the sample. So those are the population parameters that we'll be interested in this section. And those are the sample statistics that we'll be interested in this section as well. Now, even though the quantities up here are unknown, under the right conditions, we get this sample in a legitimate way by the appropriate randomization process. We can still say this: mu, which is our unknown, is approximately equal to the sample of the mean, and sigma, which is also unknown, will be approximately equal to the standard deviation of the sample, which will be S. This will be something that we come back to quite often when we get into our statistical procedures. So that's our definitions that we discussed so far. We're going to apply that immediately to this example to get started. Any questions first, folks, with the terminology? Okay, so this is, in my opinion, sometimes the hardest part about a statistics problem, either describing a parameter or describing the population. This is a real legitimate study with actual individuals. It was published in, let's see here, I have no idea when it was published. But if you're really interested in this study, if any of these studies really jump at you, I typically try to put the actual description of where you can find it. If that's ever missing, don't hesitate to email me. I should be able to track where this data set came from. If it's made up data, I'll just straight out tell you that, but I try to work with real data when possible. So let's go through this experience. This is kind of tough, but we'll do this a lot. It's a good thing to do on day one because this is, in my opinion, one of the most important first steps in doing a statistical analysis. You have to understand what the population is because we're eventually going to give a conclusion, which is extremely hard to write. We don't even know what population we were targeting. So let's begin this process. Oftentimes, if this is a homework problem, I think a lot of people will be reading this once to get a feel for it, and then several additional times, maybe 5 or 6 times in total, to really make sure we found every bit of context that's relevant. This is a skill in and of itself. We'll get a lot better at it as the class proceeds. So let's read through this. It says, the ankle brachial index, we'll call that ABI for short, compares the blood pressure of a patient's arm to the blood pressure of a patient's leg. We're told further that the ABI can be an indicator of different diseases, including arterial diseases. That sounds really miserable. We're also told that a healthy ABI is 0.9 or greater. Looks like everything in the first paragraph was just total context that we're dealing with. Going down to the next line, we have more information about this context. So a study was done. This is published in the Journal of American Geriatric Society. Here are the researchers, and let's see what they did. The researchers obtained the ABI, the ankle brachial index, of 187 women with peripheral arterial disease. That looks like relevant statistical information. And a good thing to do while you're reading these problems, start writing things down. There's like a translation layer we have to get through. This is ordinary wording, but we're working with formulas and procedures where we need a whole different way to describe this. The 187 women is a sample. So we indicate n to be equal to the sample size. And so we'll write n equals 187 women. And then just go from there. So yeah, pretty much. We use lowercase n for a sample size. And by convention, again, we often use uppercase n for population size. Although in this case, we have no clue what the actual population size would be, but we can describe it. Let's continue on the reading. It says, the results were a mean ABI of 0.64. So mean came up, but we now have to decide, are they talking about X bar? That's a mean. Or are they talking about mu? That's a mean as well. That's actually literally the next questions, value of the statistics, value of the parameters. So I'll come back to this one right here. Let's just highlight at least a standard deviation of 0.15 at the 1% significance level. This is the part of the problem that we can't answer just yet. So think of this as it's only here for the sake of a preview of what we'll be dealing with in further problems later on in the course. Oh, geez, because you can't just move that down too easily. So this is a preview information. But there is one value that will indicate a lot later on when we're doing hypothesis testing. Whenever you see this, a 1% significance level, we will later on, really not too far off from where we're at right now, write alpha. That'll denote the significance level is 0.01. So anything that says significance level is indicating something mysterious, which will come into picture once we get into hypothesis testing. Well, that's the readout of the whole entire problem. Our job now is to describe the underlying population of interest using the context. When it says using the context, what it means is I can't say the population is the entire collection of individuals that you want to learn about. I mean, it's true, that is what the population is, but this word right here is kind of inconvenient. We need to say what the population is in this particular study. Again, I find it's pretty tricky, but some people are really quite great at this. Any volunteers for what the population ought to be in this situation? And no worries if you aren't sure. This takes practice for sure. Well, it turns out that would be the sample itself. So we want a larger collection of individuals which will be considered the entire population. So how do we know that 187 was a sample? It came from this statement where it said, the researchers obtained the ABI of 187 women with the peripheral arterial disease. That's not all women with that disease. So that's got to be the sample right there. But once you know what the sample is, we reverse engineer this statement and now describe the full population. Sorry, I missed a hand up here. Patients of all sex? Not quite, because if the sample says it was 187 women, the sample is a subset of the underlying population, which means our population consists only of women in this scenario, by the relationship of the sample being subset of the population itself. Yeah, go ahead. You got it, that latter response there. The response from the class is the population should be all women with the peripheral arterial disease. That's the major objective of this study, to understand that disease better. So let's write down here, population. I guess we should start with something that makes this a sentence. The population is, I like when you said all. Putting all in there is a great way to say you're really looking at a population. I'm not going to lose credit if you don't say that, but this is excellent emphasis in your description. So it is all women with peripheral. I do not know how to spell this thing. Let me see if I can find where that was listed. There it is, arterial disease. So that is what we want to learn more about. That's the whole objective of this study. But notice there's major challenges. It's impossible to contact or even investigate who all women with this disease would even be. Even if we restrict our attention to just Idaho, that's an enormous task. It is probably impossible to do. You can't do medical testing on every single person of a sex in a state, for example, to try to determine that population. But that's okay. We can still work through the sample. Yeah, go ahead.
In general, the population is a group of people. It will often be a descriptive sentence, not a numerical value.
Yeah, exactly. That's correct. So the response in class was the population that we indicate is just some qualitative description, but the thing that's the numerical value, it doesn't go here. It would be that thing. The parameter itself has the numerical value, and to the right, it describes the numerical value as being the average, the mean of a population. That's this down here, the population of all women with that particular disease. Other questions or comments so far? Okay, well, we're right about at the mark that we said we would end class at, and I don't want to be a liar. So let's do part B, and then we'll call it a day. If you have any questions right after class, I'll be available, so don't hesitate to ask. So in determining the population, sometimes it's actually easier to start with a sample. You can find a sample once they mention a quantity of individuals or objects, whatever the study is about. A lot of times it's a red flag. You're dealing with a sample right there. In fact, we wrote down, the moment we saw 187 women were used in the study, and the sample size is 187 women. And we already know the sample is a subset of the population, so you're not required to be redundant if you feel like you are being redundant. You can simply say down here, the sample is the 187 women used in the study. You don't have to say once again that these women have peripheral arterial disease. It's already implied the moment you say you're dealing with a sample. It came from the population of women with that disease already. So if you just said the sample is 187 women, that would have been totally fine if you decide to be more terse than what we wrote down right here. What we'll do when we come back next class, get into a little bit more information on actually describing the parameters, saying what the values of the statistics are, and then we'll start the course in more earnest, start working with data, producing graphics and the typical thing you'd expect in a statistics class. But this is a good starting point because this kind of describes the overall objective of the whole course right here. These values, the 0.64, for example, that's just the sample mean X bar, which means we have an estimate of mu. And still, here's the reason this course is 16 weeks long. That estimate is worthless to us until we can describe the error in making that estimate, its reliability. That's why this course is so long. It's fast to make a point estimate. It's hard to say what is the margin of error in that estimate. That's what we're going to spend quite a lot of time doing. But have a great evening, folks. I'll be here if you have any further questions. And otherwise, we'll be back here on Thursday on part C and example 1 of these notes. Have a great night, folks.
Have an excellent evening.
Thanks, you too. Any
I
questions?
just wanted to make sure I was downloading this right.
Awesome.
So let's see. I push this here,
Yeah.
then it brings me, and then I'm doing Mac because I'm on
Oh, awesome.
Apple. And then you said to push base, but I don't.
Oh, yeah, you're right. So now they're asking for Apple Silicon, M1 chip, M2 chip. Is that what this machine is here?
Yes.
Looks like you probably want to use that one then.
So I just push that, then it's done. And so do I go back to here?
I would go to this file first,
to
and here's where you need to install that.
okay. So, continue. Okay.
Pretty fast chip.
And then I want to keep that, right?
If you want to move, I think that's the install file, so it would be
Okay.
safe if you trashed it. Probably doesn't make a whole lot of difference
Okay.
either way. It's a pretty small file.
And then now I go to the RStudio.
Yeah.
Okay. And then
Oh, wait, sorry. This one you want to kill the download on,
okay.
because I forgot about this. You have to scroll down to go to the Mac
Oh.
options.
That's right.
So you want that file there.
That one.
That's the bigger one, it looks like.
Okay.
Funny how it says
I know,
14
it
seconds
started
for
at
like 14
14.
seconds. Yeah. Yeah, that looks like that's the install file, maybe. Or
Open. Settings.
you
Oh,
got it.
there
Yeah,
we go.
that's the program.
Delete.
Awesome.
Okay, thank you so much.
Yeah, you bet.
Have a good night.
You too. Oh, sorry, Hayes, I missed your chats there while I was working with the other student. Yeah, I've heard that the fully online asynchronous calculus section is pretty rough, but I'm glad you got through that one. I agree with it being called brutal. It's great working with you again, Hayes. I really appreciate all the questions that you asked in class. I feel like a lot of times you were kind of like the leader in the trigonometry class, asking questions on behalf of everyone else. So I really appreciate that. Have a great night.
You do like today also I wanted to open my mic, but one of my cousin he also had an online section at the same time. So I was like, okay, we were working at our study room together. So I
That's kind of cool. Awesome.
yeah, see you Thursday. Thank you.
Yep. Take care.